All right, here we go. We're going to talk about how to administer a secure network. We're going to list and describe the functions of common network protocols. We're going to explain how network administration principles can be applied and define the new types of network applications and how they can be secured. What types of protocols are we going to have? Well, we've kind of talked about them quite often as TCP/IP, right? Transmission Control Protocol, Internet Protocol. That's the most common one you're going to deal with. Well, what is IP? Does anyone know?
Internet protocol.
Yes, it's Internet Protocol. It's a layer 3 protocol, but what is it?
Open systems interconnection. Protocol network. Layer 3.
Quit reading it to me. What is it?
Looking at you while I'm saying it.
It's just when I slowly drift into
What is TCP? It's Transmission Control Protocol. It's a layer 4 protocol.
Yep.
It is what establishes that direct connection between the 2 points. Okay? So TCP/IP uses a 4-layer architecture: network interface, internet, transport, and application. So here's what you have. You have your TCP/IP model. You have your network, your internet, your transport, and your application, right? What about ICMP? Anyone know what ICMP traffic does? Come on, think about it.
Is that for like mail servers?
Nope. ICMP, Internet Control Message Protocol. How many of you have heard of ping?
Packet internet broker.
Ping traffic, that's what ICMP is. Trace route, those are ICPM requests. Okay? That's what communicates and tells you the information and errors between devices. They're typically 8 bits, or the type part of it's 8 bits, code part is 8 bits, and you have a checksum of 8 bits. It's a 32-bit pack, okay? You have network unreachable, host unreachable, protocol unreachable, port unreachable. So if you get a 0, 1, 2, 3, y'all have seen those before? When you're sending ICMP traffic like pings, destination unknown, network unknown, host unknown. Here are all your unreachables and unknowns. If it gives you a code, destination unknown, code 3 or whatever, port unreachable, it tells you exactly what it is. ICMP, attacks that use it. Network discovery. If I'm trying to find out what's all on your network, I'm going to use an ICMP attack, okay? Because it lists me every type of NetBIOS device that you have on your network. It'll tell me what ports you have open, a lot of stuff. If I'm going to do a Smurf denial of service attack, where I'm sending all these ICMP traffics to flood your network, that's what I'm going to do. I can do a ping of death by sending you continual pings. Do what?
I said that's always fun.
Or I can take all your ICMP traffic and redirect it to a specific port or specific service to shut your system down. Okay? SNMP was first introduced in 1988. Simple Network Management Protocol. Basically what it does is it allows you to remotely manage and monitor your network services and configure network devices. How many of you are familiar with console ports, telnet ports, things of that nature? That's what SNMP does. It allows you to get in there and execute commands remotely. All right? SNMP at first was a security nightmare. Until version 3, it really wasn't stable. They didn't secure their passwords and usernames very well until version 3. So you can just imagine what nightmare that was, because anyone could go in and change information. All right. DNS. How many times have we hit on DNS in this class? Domain name system. All it is a TCP IP name that is mapped to an IP address for the symbolic name, right? It's just a database of mapping a URL name to an IP address. That's it. This is what the database sees. It looks like gobbledygook to you, doesn't it? So let's follow it. Step 1, I'm looking for Nashville.com. It hits our DNS. DNS says, okay, I'm looking for .com. .com goes over here, kicks it back. Okay, the .com is going to be the 1035. So I've looked for 10.35. Now I'm looking for Nashville.com. Well, it comes back. Nashville.com is the 206. So I go over to Nashville, and I find out Nashville is 158, and it kicks back 158.24, and then it comes back 158.24.39, or 3.9. And that's how it gets it. Make sense?
I thought the DNS servers were set up in such a kind of a networked way that if one went down, there was another route.
It is.
But
It's just trying to make it simplistic here.
no, I understand that. But like, I have a friend who's up in Ohio, and his whole area, nobody can get internet in the entire area right now because the DNS server went down.
Their root DNS went down.
Their root DNS went down.
Mm-hmm.
Which one of those is this?
That would be
That one.
right here. In this picture, it would be this one.
So it's not. You can't just connect it, and it doesn't like automatically just go out and find another one and keep going. I mean, surely there's more. than one
You would think that there would be multiple routes, but it depends on their, like AT&T is having a lot of issues right now, nationwide, with their particular network service, and so if he's on AT&T, that could be the issue. Now Cox is not having the issue, so it could be AT&T's DNSs that are having the issue.
That would like take out the internet for an entire area.
Yes, if that's their service area, yes. I know AT&T was having it last week here in Oklahoma City. Shawnee area was out. If you were on Uverse, you didn't have internet for a couple days.
That one sucks.
That'd be some unhappy people.
Oh, there were a lot of unhappy people. Communications Federal Credit Union, you couldn't get into them. I was calling up, they were asking me, are you on AT&T? That was the first question they asked me. I'm like, why do you need to know that? I said, no, I'm on Cox. And they go, okay, well, then you can access online banking. And I said, okay, why? And they, well, their AT&T's having issues. I said, okay. I said, but if I was having issues, then why would I be asking you about internet banking? Because the site wouldn't have come up. And she goes, oh, that's true. I said, I'm kind of an IT person. Would have kind of figured that out. She's not used to that kind of troubleshooting, but it was just kind of one of those things that you're like, to us it's common sense, but to a normal person, a non-IT person, they all say the same thing about us too. You know, medical people say normal people when they're referring to non-medical people. So it's just, you know how it is. All right. DNSs can be targeted. DNS attacks, just like ARP attacks, ARP poisoning, same thing. What's the difference between a DNS poison attack versus an ARP poisoning attack? Anyone know? What's the difference? ARP takes the MAC address to an IP address versus a URL to an IP address. So if you change either the URL or the MAC, it depends on whether you're ARP or DNS, you can poison those tables. Okay, that's the difference. TCP/IP, you can have file transfer protocols, or the secure transfer protocol, which is called SCP or SFTP, but normally we call it just SCP. You can do it, or how many of y'all have heard of TFTP, Trivial File Transfer Protocol? Just one? TFTPs? How many of you, just two of you? How many of y'all ever dealt with routers and switches? Just, okay, if you've dealt with routers and switches, then you know what TFTP is, because that's what you have to up and download your start and run configs. Your configuration files, when you download them and upload them, it has to be TFTP. Using a TFTP behind a firewall can present challenges because it's either going to be an active mode or passive mode. Depending on your network, will depend on what type of mode that you need to do it. It's usually best to do it in passive mode behind a firewall. FTP clients can be a variety of different things. Here's FileZilla. I really don't like it, but you can, because to me it's too cluttered. But you can, there's several different tools. I usually like WSFTP. It's pretty simple. What is vulnerabilities of FTP? Since everything in clear text. Like I said just a minute ago, you have the SCP, or your secure transfer. What's the difference between here? FTPS and SFTP. FTPS is just a secure tunnel of FTP versus secure FTP. They're two different things. Just keep that in mind.
So SFTP would use encryption.
A secure FTP uses encryption. Your FTPS is just a layered, it's just like a tunnel. It encrypts the command, that's all it does. Make sense? Know the difference. Secure Copy Protocol, your SCP, is just an enhanced version of the Remote Copy Protocol. It encrypts all your files and commands, but it cannot be interrupted and it cannot be resumed. And basically that's going to be your Linux, your apt-gets, things like that. Does that make sense?
It sounds more secure, then why don't they use it more widely?
Oh, that's how the SCP, that's all it does when you're downloading anything in Linux or Unix. Once you start downloading, you can't.
I mean, why don't other platforms, do they have something just as
It's just FTP on Windows based. IPv6 and IPv4. IPv4 came out in 1981. There's only 4.3 billion IP addresses for IPv4. How many computers do you think there are?
more than that?
And I'm sure they thought that would last them forever.
Yes, they did. IPv4, they say, has security weaknesses.
No.
Why would an IP address have a security weakness?
0 weaknesses.
Why would an IP protocol have a weakness?
Just in general, why would a protocol have weakness? Because it says we're assigning things based on a certain pattern.
You can take advantage of some of its parts. You can use some of its parts in a way that it didn't mean to be used.
Mm-hmm.
At the very least, we know from the Class A, Class B, etc. I mean, I'm not sure how useful that information is, but I can say, oh, that's part of a bigger network or smaller network.
Yeah, you could. You can figure out networks, subnetworks.
Ignoring all the other stuff that we can do.
But with an IPv4 or IPv6, could you really figure it out as easy?
Not really, because there are a lot more.
There's your difference.
Can't you manipulate the flags in the IPv4 to do stuff? Or something? Was it that one?
I don't know if you can manipulate the flags.
Like you can change the flags to do such and such, and you can kind of do some extra things with it that you're not really supposed to do.
I don't remember.
I think it was the flags.
It might be.
Because it was something that was in the old one but wasn't in the new one. They just took it out.
That could be because it's not in the new one.
So there's no time to live on an IPv6 header?
Well, there's a hop limit.
Mm.
Okay.
It's by the hops.
Good. 'Cause
They took out time to live because you have 30 hops.
oh, wait a second.
Just a more accurate name.
So if I did my awesome, whatever the things in the movies and whatever, where the cool hacker kids like, haha, I'm actually going through 8 different IP things, and I'm not in California or Bangladesh or whatever, but you think I am, etc. Movies. Is the hop limit going to affect that then? Where if I went to set myself up as being somewhere else, assuming that I'm actually am communicating there, that would, the hop limit of 30, would that create some issues potentially? If we have networks that have a bunch of different segments?
You could.
Yay!
IPv6 provides enhanced security features. You have cryptographic protocols, and it'll prevent IP packets from being altered, unfortunately. You can look at the difference between your comparisons there. Network administration principles. How are you going to administer a secure network? Well, we could do it by doing a rules-based management approach where we set policies, procedures based on laws, research, rules, and we can make them very technical, very detailed. We can talk about security limits. We can talk about individual, physical security. I mean, we can get down to the weeds if we wanted to, right? With rules and policies. But does that really do us justice? How deep do you want to go? Think about it as a manager. How deep would you want to take your security policy? If you're a mom and pop shop, do you want to get down into the weeds with your security approach?
You want to, but you can't.
Well,
No,
wait,
don't
why
use
can't we? We're only a mom and pop store. There's not going to be that much I know there's not that much stuff to protect, but there's not going to be that many devices either. It's going to be relatively
You only need
easier.
one.
Yeah, so it's going to be relatively easier to say, hey, I'm locking this thing down completely because exactly Windows operating system or something.
I mean, you only
Did
need
you
one
play that?
access point, that's all. Not for them,
I
I mean
just
for an
started.
attacker. But I mean, it's like, it's the common thing with security on any level. It's a matter of what you have to protect versus what you stand to gain versus what you stand to lose, and balancing the two.
It's risk
That's all it
management.
is.
Right. It's just that I would think that with fewer devices, it's actually going to be easier to be more secure.
So you're saying that you believe that a rules-based management approach is more like a risk-based management approach. That you have to have you're basing your rules level on risk management. How much risk are you willing to take?
Yeah,
That would be a fair assessment.
I think so.
Matthew, you agree?
I'm remembering, I think CyberLaw or whatever, where or something where it has risk and whatever, and we might be using the wrong words for stuff, but yeah, in general,
Aaron?
everything is a money-based thing.
Yeah. Mine's the base for why you said it.
So you're in agreement with Tracy and Matthew that to have a procedural or a technical rules-based scenario, you have to base it on some sort of risk management to apply the depth of rules.
The more risk,
The higher the risk,
go in depth.
the more depth and rules that you want to do. Or the more risk that you're willing to take, the less rules that you want to implement. Okay. What about device security? What kind of device security we wanted to establish? Do we want to establish stricter device security, such as implementing secure router configurations, flood guards, device logs, audits? What kind of device security do we want to do?
Depends on your risk management, depends on what you're wanting to protect. I mean, if you have a lot to lose, then you want that to be real strict. And if you're a little mom and pop shop where you just can't afford to go in to that much detail because, you know, your IT budget is, you know, your cousin's friend, then, you know, you just can't do a whole lot. You just hope that you're okay.
Okay.
Just wondering, the difference between device and network security as far as an example, say network security, at least with, I guess, IPv4, might be that I'm actually technically subnetting each host to be on a different subnet entirely, I guess.
I would do that, but-
Example. So that way that they're all separate, sure. Device security would have to do with, like you said, the router itself, I guess, being secure whatever.
Mm-hmm.
I don't know why I needed to say that. I think I figured it out in my head.
Okay.
Erase it from the recording.
That's
You
not going to work.
basically always do as much security as you can afford, but everybody has different risk tolerances.
A network diagram basically is how it works. You're going to have your internet come into your router. Usually you have your modem or your WAN connection here. Sometimes you'll just have your regular router. If you're a corporate environment, it comes into your router. It comes into your Ethernet switch that goes out to your LAN. That's pretty much how it works. What is a SYN flood attack? Basically, it just says, I say, hi Aaron, I'm Scott. Aaron goes, hi Scott, I'm Aaron. I go, hi Aaron, I'm Scott. That's all it is. Just back and forth, back and forth, back and forth. And he just keeps initiating that conversation over and over and over and over. How long before Aaron comes up and slaps me? You know, that's that is what a SYN flood attack is. A flood guard. That is a device that allows you to protect against a denial of service. It allows you to see them, detect them, and prevent them. In other words, an IDS, a firewall, or an IPS. that can see those strings or those methods or those strings and go after them and stop them before they occur. Log analysis, they're good. However, how much time do the network administrators actually have to go and look at logs?
That's what interns are for.
All right, Tracy, have fun. Go look at some logs. All right. The types of security hardware logs, we have NIDS, NIPS, DNS, proxy servers, firewalls. Then you get into the event logs for auditing of services, success and failures. What is NIDS? Greg? What's NIDS? What's NIDS? No one say anything. What's NIDS? Ryan, what's NIPS? Brandon? What's NIPS?
I'm trying to remember because I learned that back at the phototech.
Sean, what's NIDS?
Pass?
What?
He said pass.
He wants to use a phone friend.
0 for 4? Really? Daphne? What's NIDS?
Is it a type of application that helps with intrusion detection?
What would be the N? You got the rest of it. What's the N stand for?
No.
Huh?
I don't know. I really don't know. Network?
Yes. Network intrusion detection. What would be NIPS?
Prevention?
Network intrusion prevention. NIPS and NIDS. Y'all will need to know that. You will see it on your final exam.
So does that is it like the mother name of a bunch of different things that do that?
Okay.
Firewall.
No. You have IDS and IPS. Okay. That's intrusion detection and intrusion prevention. Those will be on your local devices. Network intrusion and network intrusion, detection and intrusion prevention are going to be a network device, like a firewall, that would be on for your entire network. They're two different layers. Does that make sense? If you have the N on it, protects the network. If it doesn't have the N on it, it's on a singular device, such as a computer or a server.
It's like a classification of something.
Yes.
It's not like, oh, I have NIDS. It's what NIDS do you have?
No, NIDS would be for the network itself.
Right.
And then,
But there's not something you go by called NIDS.
no.
That's what I'm saying.
Right,
So
yes.
It classifies the different things you use.
That is correct. It would be like TCP/IP.
Okay.
Well, some of it's software. I mean, you could go get software for that.
Yeah, it's either software or hardware.
Yeah.
Yes. She was saying it's not like a McAfee. It's not a Norton.
Right.
It's an antivirus kind of thing. It would be a term like that. That's what she was referring to. Okay. Not going to worry about those. Firewall logs, I'm not going to worry about that. Network design management. As your network grows, you're going to need to reconfigure your risk management assessments. Network separation. You're going to need to resegment, reconfigure, resubnet. Right, Aaron?
Yeah.
How are you going to physically separate computers? Ryan?
Physically separate them
How would you physically separate computers?
from a different room.
Well, you could do that. You can put switches in between them. You can put routers in between them. You can put hubs in between them. Even though a hub won't really do it, a switch may or may not do it. Depends on how you have the switch configured.
Have virtual LANs. Then like,
Yeah, that's the only way you're really going to have them separated. Or you can do air gap switch,
I don't know what that is.
wireless.
Oh.
I'm not going to worry about loop protection. Um, well, a loop protection basically all it does is it looks to find the best way to get to the destination without getting stuck in a loop and creating broadcast storms by flooding your network. Okay. VLAN, basically, it's a virtual LAN. Even though they're all physically connected to the same network, is virtually can only see its own virtual network, and that's it. A VLAN won't connect to another VLAN unless they're both connected to a router. So if I can have two VLANs on the same switch, they will never see each other unless they're connected to a router. If I connect a router to that switch, then they can talk to each other. But that's the only way they're going to talk to each other. And if you really want to have fun, configure empty switch ports to an empty VLAN so that anyone that plugs in won't be able to connect to anything anyway. And you always want to change your default VLAN. Port security. This is one thing I always do. I disable any unused ports. So I have to physically go in and turn them on through a management console if I want to turn on a port for someone to use it. So if we add another computer to a port, I have to go in there and physically turn that port on. I can also do it with MAC address filtering. It's where I have to know the MAC address for any other computer that's plugged into that won't ever get access. Only that computer that had that MAC address will get access on that port. Or we can set it to where it limits it to the first MAC address that's plugged in. That's going to be the only MAC address that gets on there unless I reset it. I do the 802.1x. Basically, it blocks all traffic on a port-by-port basis unless the client is authenticated. So this is it. The supplicant asks to join the network. The authenticator asks to verify identity. Sends it to the authenticator. The authenticator sends it to authentication server, who then verifies the identity. Then it'll approve it if it's approved by the authentication server. It'd be like Aaron says, Scott, I need access. I said, okay. What's your last name? He says Smith. I say, Daphne, do you know Aaron Smith? She goes, yes. I say, okay, you can get into the room. That's all it is. Virtualization, or you can secure it by putting all your stuff on one. Without regard to physical layout or location, you can put them all onto one computer. Makes it a lot easier to run things. Doing penetration testing. be done a little easier because you can do it all on one environment. You can use virtual environments to train a lot easier than you can having to do a lot of singular machines. The sad thing about, or the bad thing about virtual machines is you have the hypervisor. If it ever gets infected, you're screwed. That's the downfall about virtual machines. It can reduce cost and energy usage because you have one machine that's running multiple copies of things. Instead of 30 computers, you're running one. It's easier to migrate, update, perform maintenance. You use load balancing techniques a lot easier. You can have security is a lot less to have to worry about because you only have that one computer to have to physically secure rather than multiple boxes. Does that make sense? Think about this. You only have one 30-pound server to manage than 6 30-pound servers. Right? Let's see here. Like I said, some hypervisors do not have the necessary security controls to keep out attackers or hackers. And that right there is your biggest exploit. If a hacker can get into your hypervisor, it can take down all your virtual machines at once.
All the eggs in the basket.
You got it. Instead of having, that's why it's good to have if you are in a corporate environment, that's why it's good to have one server for each different function, if you can afford it. But if you're in a small mom and pop shop, put them all on one server, then all the corporate environments want to cut back on costs. They want to put them on that one basket. They're going to be targets for that exact thing right there. Security tools don't always adapt to the VM environment. Why?
It's not exactly the same thing. It's close.
It's close because you have virtual drives. You have virtual hardware. Virtual hardware is not the real hardware. And you're going to have external physical drives that it can't scan. That's why it can't get to the USB drives on the servers. All right, IP telephony. You notice that everything's going to VoIP now, right? Why can we selectively forward or block? Why do you think we're going towards that? Brandon?
I don't know.
You don't know? Sean? Aaron?
Well, the cable you run can have multiple uses.
We're not using all the bandwidth, the cable that we already have running.
The infrastructure's already
Yeah, the infrastructure's already there. Why not use it? It's cheaper.
and it gives you more control. You can do more stuff with it.
Cost savings. One network to manage everything.
Plus, you can tell whether the phone's up or down. If you have an active client.
What about cloud computing? Software as a service, platform as a service, or infrastructure as a service. How many of y'all have heard about those before? They're going to be becoming more and more frequent terms for y'all.
There was a news article on the BBC that they're using this now to fight crime because child porn has such a huge amount of volume of data. That's what they're marked for. So they're starting to centralize all that data amongst all the agencies in the cloud because it's the only place big enough to store it all so that everybody can cross-reference and stop duplicating work and catch people faster.
Any questions on that? What are security challenges?
You really transferred the risk to the provider. They have to make sure your stuff's confidential and not corrupt and available and all that.
Yep.
You
A
don't
lot
have
of risk
any-
transfer to them. Are they able to handle that risk?
You don't have control very much over it.
It depends on the level you choose. If you do IaaS, you have a lot of the risk still. You're putting your own server out there. They just provide the internet for it. Up to SaaS, where you just provide the software and the rest of it's up to them. So I mean, there's a lot of different as a service opportunities out there now. So it's really, what is it that you're looking for? So is there any questions on chapter 7? Have I adequately bored y'all to death today? I know you really didn't want to come in at 9:30 in the morning on the Monday after spring break and want to hear a boring chapter. Right? I know y'all are all asleep. Come on.